I'm back. Can I invite out our next panel? So we're going to explore now the idea of intelligent automation. And I guess previously automation was not intelligent. And now it's going to get more dexterous and more autonomous. And so to discuss that with me, we have, I guess on my immediate right, well,
yes.
Let's see. You're Simon, right?
Yeah.
Well, sorry, we were just talking about common sense.
Simon Thompson on my immediate left, Josh Tenenbaum on his left, and on the far left, Patrick Winston. And why don't we start with Josh? If you want to either stand or you can sit.
Sure, I can sit. We have a few slides. So. I'm a little bit different. I don't have the clicker if somebody else can advance. I'm a little bit different than many of the AI researchers here. I'm sort of half an AI researcher and half a cognitive scientist. I'm in the Brain and Cognitive Science department, also in the Center for Brains, Minds, and Machines, along with Patrick here. And in the work that I do, I try to both understand how humans think in engineering terms, and then use that to build machine intelligence that's smarter in more human-like ways. So if you go to the next slide here, echoing many points that we've heard, including from Eric just right before, we have all these AI technologies, which are systems that do things we used to think only humans can do. But we don't have any real AI in the sense that none of them have a flexible general purpose intelligence. None of them learn for themselves. Just as Eric said, AlphaGo or any of these other systems are really built by human engineers and programmers, often large teams working for years at a cost of tens or hundreds of millions of dollars to build some of these systems, okay, if you take the total cost into account. None of them learn for themselves like you do. They each do just one thing. AlphaGo beats the world's best, but it can't drive to the match. It doesn't even know what Go is or that it's playing a game. So I'm interested in what the gap is, and that points to the future of AI and jobs on both shorter and longer time scales. So if you go to the next slide, and if you really pay attention to just one thing, it's this. Today's AI technologies are really driven by successes in pattern recognition. That includes deep learning and many other kinds of machine learning systems, approaches. But human intelligence is about many more things than pattern recognition. In particular, we're interested in the sense in which it's about modeling the world. So our ability not just to see patterns in data, but to explain and understand what we see, to be able to imagine things that we have never seen, to be able to make plans and solve problems to make those things real, and then learning as building new models of the world. Okay? Now, if you go to the next slide, I will say that our ability to capture in engineering terms the human abilities to richly, flexibly, and so quickly model the world, we're decades away from being able to do that at the scale that you could deploy in industry at Google or any of these other companies. But progress is happening, and just to point to this, this isn't a research talk, but in our group, like the thing that you covered a couple of years ago, we've made some, and a number of other people have made real advances in one-shot learning, how to get machines to learn like humans, not from thousands of examples of a new concept, but maybe just one example. Or, Eric was talking about common sense, Daniela asked him about that. We're interested in aspects of common sense that even a one-year-old has, even a 3-month-old. There are ways in which even a 3-month-old baby, and we study young babies in our group, together with some of our colleagues who are developmental psychologists. A young baby has a kind of common sense understanding of the objects in the world, like the things in front of me, the cups on the table, the people around us, the ways we can act and interact with each other. That is the basis of so much other learning. I'm thinking in the sense of jobs, there was an article by one of your colleagues back at the Times, I think it was Claire Kane Miller, from a couple of years ago. All I ever need to know, I learned not in kindergarten, in preschool, right? This basic common sense understanding of what other people want and how to get along with others and how to cooperate. If we could understand that in engineering terms, it would be quite significant. So just on the very last slide here, if you advance it, I think in the near term, again, just echoing many points we've heard from others, AI is affecting jobs, most jobs, because most jobs do involve some component of pattern recognition, right? It's what we say about so many of our jobs, that it's not rocket science, right? But human expertise and this very, very basic common sense is going to be essential, right? The idea of having a goal and doing pattern recognition in the service of goals, that's not going away. So instead of talking about AI with humans in the loop, I think it's important to understand that it's, jobs will continue to be done by humans with AI in the loop, or automating tasks, as some people have said. At the same time, there's still going to be many effects of AI on jobs, all these issues which people have been talking about, and all of you I know are thinking about. But I just hope we can talk about longer term. What are ways, as we start to be able to give our machines some actual sense of what a goal is, and what is a common sense understanding that we might share? How will that transform the possibilities for jobs and machines interacting as partners with humans?
Thank you. Simon, you're next.
Okay. Okay, I'm Simon Thompson. I work at BT, which is a global communications company. And I've spent the last 20 years trying to make things better for people with AI. So at the minute, I run some research teams delivering AI technologies to the company. But for a long time, I built AI applications, and I worked with small groups of people to deliver AI applications using technologies like AI planning and scheduling, optimization, and of course, machine learning. And we did that in the front office with CRM systems, in the back office with work allocation systems, work design systems, network optimization systems, and in the field with test and diagnostic systems, so network telemetry interpretation, this kind of thing. And there's an ongoing portfolio of work to do, a whole load of stuff to do. And I'm very passionate about it. I think it's a great thing to do because people face really great challenges in their work lives. I think if you go out into a Fortune 500 company and you go and look at the work that people are doing in contact centers or in the field, you'll find there's a huge amount of frustration, a lot of repetitive work, a lot of things that get in people's way. What really struck me some years ago was we asked some of our contact center people what they wanted, because we'd had a string of, well, I'll say it, failed projects, and we didn't really understand what had happened. And we actually asked these people, what is it that's motivating you? Why are you doing this? What are the problems? And one of the things that came out of that, loud and clear, was that they just wanted to help customers, right? That was their motivation. They were there to help. And whatever we can do to help them achieve that purpose, I think, is a good thing. So I'd like to make some observations about what happens in an enterprise and why doing this has proved to be quite challenging and difficult and keeps me gainfully employed and keeps my people employed. One thing we see is that a lot of times you can implement an AI solution within a workflow quite easily. So on the left, we have the typical situation where you've got a new business process, maybe you're a startup, or maybe you've got some new technology and you can roll something out really easily. And this has happened to me precisely twice in 20 years. So once was social CRM. We had an opportunity to build a new CRM system from the ground up, and we could put AI in it, and it was great, and it worked. Another one recently, we changed our data infrastructure, and we were able to build a new application we couldn't do before to manage calls, nuisance calling, and we were able, again, to just drop in the AI implementation into that. Now, the more common kind of issue is on the right. That's an enterprise AI stack, an enterprise AI IT infrastructure. And this is very typical, and the reason is because big companies, Fortune 500 companies, are not one thing. They're a great collection of old companies that have been bought up and stuck together and re-engineered and rebuilt. And this has led to these huge, complex enterprise IT infrastructures, which are not well understood and studied, in fact, it turns out. And we know that if you read the IEEE Spectrum that was in 2015, you'll be able to read some of the history of IT projects that have gone horribly wrong and cost hundreds of millions of dollars. And this means that we're stuck with this kind of infrastructure. It isn't easy to drop new intelligence into it or to re-engineer a business process. There's massive risk and there's massive capital commitment required, and this gets in our way. And this is a big challenge for AI in the future, I think. Now, one of the reasons that there's a challenge, Josh talked about his work, which is absolutely essential. We need to get away from this perception that we've got autonomous agents available for use by AI researchers. I worked on autonomous agents for years. I love the idea. It's a brilliant idea. This is great research. We've got to do more of it. They don't exist in the state of the art right now, as far as I can see. And it causes two problems. One is a problem of perception. So lots of people believe that this is available and that somehow AI groups like mine are hiding the magic technology from them. And we've got to be beaten into producing it. We've got it locked in a box somewhere. We could just trot it out and use it, and somehow we're obtuse or undermining things by not putting this forward. So that perception is really difficult for us to handle. And this is something this audience could actually help with. So we heard about the breakthroughs in speech recognition earlier, and it is true that on the NIST 2000 conversational data set, we've gone to 5% word error rates. But the NIST 2000 conversational data set is not the real world, right? That's not the problem that I face transcribing speech in from my contact centers, because I have multiple speakers in the channel, I have background noise, I have regional accents. It's really harder than that. And if I could get 5% word error rate, it would be brilliant, but I can't, not with the deep models that are available to me now. Okay, so we need to actually move away from this idea. We need research that helps us get there, and we need to understand that actually right now we're doing loads of programming. I've really overrun, so I'll cut to the chase. I think we really need to do more because we face societal challenges. Everybody said it today. There are things that we need to do. Prosaically, for my company, we need to free up people, and we need to free up cash to do new business, right? There are new technology opportunities coming through. Every telco in the world needs to get into 5G. We need to invest in that. We need to move our people onto doing that. We can't leave the old business processes and just abandon them. We can't do that. That means somehow we've got to do those business processes more efficiently so we can move into the new business processes. So that's the prosaic challenge. The bigger challenge is dealing with demographics, climate change, social justice. AI can help us do that, so we've got to do that. So my appeal for help, Josh, please, more flexible AI, more human-like AI. We desperately need it. Another research challenge, understanding more specifically what cognitive activities are going on in a business process, because at the minute it's witchcraft. We go and we look, we don't really understand what's happening, and we find out in the middle of a project, it puts 20% on my budget, the project fails, it's disastrous, I can't afford it. And the other one is methodologies for systematically applying AI technologies, identifying how to actually get them into processes in a systematic way. I'll shut up now. Okay.
Thank you.
Patrick.
Thank you. Well, let me begin by saying I'm glad to be here today. The talks have had a very soothing effect on me, especially Eric Schmidt's, because my takeaway is that in terms of future work, Professor of Artificial Intelligence will be the last job standing. So I thought of putting together some slides here for my introductory remarks, but I remember that the last time I tried that, I tried to cram a 1-hour talk into 4 or 5 slides. It was horrible. I vowed never to do it again, and that was 35 years ago. So instead of doing a presentation of slides, I'll just ask myself a question, and the question is, what do you make of all this? And I'll begin my answer by saying that 5 years ago, I led a very quiet life. And then Elon Musk said that artificial intelligence was our biggest existential threat. And more recently, Vladimir Putin said that he who owns artificial intelligence will rule the world. When I heard that, my first reaction was, sounds good, where's my computer? Let's go. But then I said to myself, what can these people possibly know about artificial intelligence? And I concluded that what they know about artificial intelligence is a consequence of the miracle of machine learning. And machine learning, in my view, is another name for computational statistics. So whenever I hear scary remarks about artificial intelligence, I substitute the word statistics and see if it sounds good. So Vladimir Putin might have said, he who owns statistics owns the world. It might be true, but it doesn't have the same kind of effect. So, yeah, there I am on a roll in my answer. But to address the subject of the panel, automation challenges, opportunities. I think things haven't changed much since 1985 or so. Back in those days, people were saying that expert systems will rule the world, at least economically. And we discovered some things about that. What we discovered was that AI can make a contribution to ordinary automation, and ordinary automation will replace people in some routine types of work. But the efforts back in the 80s to replace human experts with AI systems ended up replacing the human expert with an AI system, but the human expert still had to be there. So many companies were started, much venture capital was spent, and a lot of companies that had that idea went broke. The ones who didn't go broke were the ones who said, if we can put people together with intelligent systems to do something that can't be done by either alone, some new thing, that will be where the economic value will lie. And I think that's still true today. Oh, and now I can abbreviate the rest of my talk by just saying I agree with everything Josh said about where we are in the technology. We've discovered a lot of useful engineering knowledge about recognizing things, perceptual things, but we still know very, very little about what goes on inside our skulls. And until that happens, I think the economic value in that kind of AI, the kind that's not perceptual, it's more cognitive, the economic value will be in combinations that put things together to enable new kinds of work to be done. Our colleague in the Sloan School, one of our colleagues in the Sloan School, Tom Malone, is writing a new book on a subject of what he calls cooperative intelligence or community intelligence, or the kind of intelligence you get when you put lots of people together or lots of people in computer systems together to do things that can't be done in any other way. And that's where I think we'll be going for the next 5 to 10 years. But that's not to say that eventually we won't understand what goes on inside of our skulls. I don't think it's going to happen in the next 20 years, but of course when you say stuff like that, you have to be careful because it might just be a failure of imagination. And so when I say it won't be done or can't be done or something like that, what I really mean is I will be very surprised if you can do it that way, or I will be surprised if you can do it that soon. But we will eventually do it, and we will eventually have systems that are as smart as we are in every possible way. And is that a scary thing? I think there's a positive side, because I think what we'll end up having is a better understanding of ourselves, a better understanding of what can go wrong when we think, and a better understanding of each other. And that can't help but be a good thing. And there will, of course, be unintended consequences that would have to be dealt with. But on the whole, I think that understanding ourselves and how we think will have the same kind of role in understanding our place in the universe, our evolution, our biology. It will be the next natural step in understanding ourselves, and that's got to be a good thing.
Thank you. Once again, I want to encourage you to ask questions via Twitter, and I'll do what I can to see them. You have the long view, Patrick. There seems to be this field has overpromised and relatively underdelivered for a long time. If you go back to McCarthy, he initially thought it was a 10-year project to build a thinking machine. We're in this particular period right now, which I'm trying to get a sense of how skeptical you actually are about the progress that this community feels that it's made.
I guess I'll try to be a little skeptical because someone needs to be. Yes, we've always said that human level intelligence is 20 years off. And of course, eventually we'll be right. But probably not this time around. I think that if you don't know anything about artificial intelligence, what you need to know is that what we've got today is impressive. It's astonishingly useful from an engineering point of view. But as far as understanding our own human intelligence, it's only a small part of the story. There's a much bigger story yet to be told.
And you know, let's forget about calling it artificial intelligence. There's that notion that planes fly without flapping their wings. Could there be a very different kind of intelligence that would emerge from this world that would have nothing to do with human intelligence and yet would be very powerful in its impact on the world?
Yeah, sure. Yeah, no doubt about it. We are a particular embodiment, and we have our limitations. A system that could read all of the books in the Library of Congress would have assets that we can't possibly have. So sure.
Can I just, because that's a very common metaphor to talk about, you know, the bird versus airplane one. And I think, you know, just as Patrick said, and just as many people have suggested, there are certainly other forms of intelligence besides ours that are more like the 747. But especially in the context of work, and especially if we're talking about groups of humans and AIs in some ways working together, think about like a bird flock, right? Birds are very intelligent creatures, many of them, and they're very social. That includes the way they fly and navigate. They take signals from each other, but also, you know, some birds make tools and they have culture and they pass them on. And so birds have a physical intelligence, but it's intrinsically social, much like humans, right? And if you're gonna try to think about, say, getting a machine that could engage with a group of birds, and, for example, help them fly in a better formation or towards where they want to go and not get lost or out of formation, right? Or pass on culture. That bird or that robot's going to have to be a lot more like a robot bird than a 747. It's going to have to be recognizable by the other birds so that they can coordinate with the mechanisms that evolution has put into their brains. That's what I'm talking about when I you know, again say the common sense that you have even in a very young child. So in the context of machines and humans interacting, you know, think about if it was only 747s and birds interacting, well, we know that doesn't usually end well for either the 747 or the birds, right? But if we could build robot birds that don't have to, you know, the inner workings don't have to be exactly like a bird, but the API, if you like, the interface systems, which we have intuitive theories in our brains for how those work in other brains, then, you know, that's a place where trying to understand some aspects of what goes on inside our brains will really actually advance the possibilities for AI in, you know, all sorts of economically useful ways.
Josh, you talked about the idea of learning from small amounts of data, and what really intrigues me about that is that everybody here is worshiping at the Church of Big Data. Are these guys building Maginot lines? You know, we also there was a discussion. I mean, I think Sam was talking about the possibility that there were these elite corporations that had access to the data and that gave them advantage. What if you're right? What happens to the world if we in fact learn to learn from small data? Well, the way we do, I assume.
Yeah, I mean, I think that's an interesting thing we should all consider, right? I mean, we think that's central to building intelligent machines that are actually flexible, right? It's like Daniela was talking about, learning to learn or transfer learning, right? They're related, it's the same kind of thing. You want machines that don't just have to be engineered to do each new task by humans, but you want, just like we expect in other people, that we want our partners in our work to be able to pick up on new things very quickly. But that doesn't mean that, you know, big data, that they're not Maginot lines. I mean, that they're fighting a real war. Like when Putin says, translating as Patrick did very insightfully, you know, whoever controls statistics or computational statistics controls the world. Like, well, actually, there's a lot of truth to that. At the same time, it's really interesting, you know, where the interface between these kinds of things. I could give one anecdote that I learned something from. So earlier in the year, I went and gave a talk at Hudson River Trading, which is you know, one of the leading new data computation-enabled hedge funds. They claim to do 5% of daily trade volume. So they specialize in high-speed training. And I asked them the same question you're asking me. Why are you interested in me? Like, I study how people learn from small amounts of data. Common sense. Why does that matter when you're dealing with picoseconds or something like that? And they pointed out something which was very interesting. I hope I'm not giving away any big secrets, but they told me about it over lunch, so I assume it's okay to talk about. They said, look, you know, sometimes we come up with an algorithm that makes us a lot of money. Now, these algorithms have to be really simple, right? Because if they work really, really fast, they have to be pretty simple, and speed is what it's all about. And then we find that after a little while, the algorithm starts losing money. Why? Because someone figured out what we were doing and designed another algorithm that was just a little bit smarter to beat it. So there is an example of a human doing a little bit of few-shot learning by the human can slow down time and look at the trading records and see, oh, it looks like somebody was poking around here doing this thing. I know how to beat that. So that's an example of, like, in the current ecosystem where humans and machines are interacting in some ways, and the humans are still out in front, but it's because the humans have that ability to detect patterns and understand what's going on from very little data.
I think one important thing to be understood is that it's not a question of just more of the same. More of the same won't make these systems like us. We are a uniquely symbolic species, and these systems are fundamentally not symbolic. So they don't have what we have and what no other animal, including all the primates, has, and that is the ability to think symbolically, to formulate descriptions of things, to reason, to follow recipes, and ultimately to understand stories and tell stories and formulate new stories and do all of the kinds of things that made it possible for us to paint the caves at Lascaux, and the Neanderthals and the chimpanzees haven't got a hope of doing anything like that. And so no system that that doesn't have a symbolic abstraction layer, as we in computer science like to talk about, no system that doesn't have that kind of symbolic layer can do what we do, and that's why the hall is full of people like us instead of long-haired orangutans and copies of Watson.
So you're particularly skeptical about those charts that show exponentials up and to the right, as being that somehow we'll get quality out of quantity.
I am skeptical about that, yeah. More magic is to be done, no doubt about it, but I think that let me say, I will be very surprised if we end up doing it.
There's different dimensions of scaling, right? I mean, there's some dimensions along which you have this exponential growth, but the kind of things that I think we're talking about here, which when you really talk, like the difference between a task and a job, that's a great distinction, right? Like the scaling to bigger tasks or doing more different tasks is not the same as scaling to jobs, let alone other things that are at the human scale of goals.
Simon, I'm super interested in the future of the call center, the future of the contact center, and you have a real world view into that. The points you made about the challenge of speech, and I've sort of been trying to pick up data points. Jan LeCun says it's rather hard to get to useful conversational agents, harder than we thought. And so does that mean that the call center with humans in it has a long life in front of it? What will happen to employment in the call center over decade-like scale?
Obviously, I don't know, but I know that it's extremely challenging to think of taking out those processes in an enterprise right now. I think a lot of people would love the idea of doing it. A lot of vendors will say, look, we've got solutions that can do this or do parts of it. But I think generating useful responses, I think especially dealing with general purpose questions. I mean, I think we saw with Watson that it was really impressive because they had the Jeopardy type of question, right? So it was a very specialist type of question. I'm looking for reassurance from the professors of artificial intelligence, but it's a specialist type of question that allowed you to frame queries into an infrastructure and produce a specialist kind of response. Human dialogues, problem solving, they're not like that. They're very freeform, they're very open. I think that when you go to people reading scripts, then you have got an opportunity to do some automation, but those kind of activities are pretty unproductive, and they're pretty frustrating for the people who are reading the scripts. And what we find is that what happens is that you automate some regular small tasks, and people end up focusing on the complex, difficult tasks that they haven't had time to do properly before. So they put effort into providing better service for customers. They help out people who need extra help, elderly people who ring in and can't understand services, and they can spend some time with them. So that
seems really important, right, across many industries, right? Like an example that I think has already been talked about, things like in radiology, machine learning systems can help to automate a lot of the easy routine parts of radiology. They might make different mistakes in reading scans than humans do, but we know that the best radiologists, all radiologists are overworked, right? And they don't have time to necessarily spend put their brain power where it really matters, the really hard cases, let alone in places, well beyond Boston, all around the rest of the world, where they don't have access to the kind of medical expertise that we have here. So if you can use machines to liberate humans to use their thinking cycles where they really matter, the humans, everybody will be happier.
And there are points on, we're talking about curves of value in any interaction, where things do go kind of exponential. So the radiology example or the GP surgery, if you can spend 20 minutes with a patient that normally you would spend 10 minutes with, and you actually pick up that they are seriously ill and you can do something about it, that's vastly valuable. That's an incredible value point. Or from a corporate point of view, if you can turn around a customer and really please them, and then they don't churn and you retain their lifetime value for another 10 years, that's a lot of revenue.
So how important is the relative importance of culture? I mean, we talked about Tay, Microsoft's great failure, but what we didn't talk about was Xiaoice in China, which was their great success, where, just for those of you who haven't heard about it, there was a chatbot that was not meant to be a productivity tool, it was meant to be a conversationalist, and in fact, it drew and still draws this vast audience of young Chinese who would have up to as many as 60 interactions a day with something that was just based on scraping the Chinese social web to give relatively useful answers. Are there cultural differences that would lead to different outcomes in the kinds of systems you're building?
I think there are cultural differences. That every company, every organization has a culture. I think that you definitely have to understand the culture of the place where you're deploying a system of any kind into, and if you don't, then you are more likely to fail than succeed. So I think that comes down to the soft skills we've heard are going to be valuable in the future. People need to be able to go out and understand and to, something that we haven't talked about much today is asking people what they want and trying to understand what kind of interventions they would like in their working lives, what kind of working lives people would like to have. I talk to the graduates at work, the new people who come in, and they seem to want some different things from me out of their working life, right? They seem to want more flexibility or more mobility, perhaps. And then when I talk to other people, I was talking to somebody at lunch, and they were pointing out to me that when they were 20, they wanted that too, but now they're not 20. And I dimly remembered back, and I agreed, And I think that this sensitivity is what we need.
Yeah. This is perhaps a philosophical question, I'm not sure, but Enrique Shada asks, will humans ever know what the essence of life is to make systems that reflect it? Now, I'm trying to, so is that the same question we were just struggling with? How can we build something that we don't understand?
The essence of life meaning like where life in the universe comes from, or what our goals are. I mean, I think fundamentally, this is a fundamental challenge in AI and also in cognitive science, and it matters for work because we all want a purpose in life. Like what's the difference between a good day and a bad day, right? Think about it for you. I mean, I know when I'm in my own reflection, it's like if I feel like I made progress or I'm even making progress on something that really matters to me, right? And it's given how much of our time during the day we spend on work, then that's essential to being human, right? It's why people want to work, even if they don't need the money, right? So this is... And
there's a thing about freedom and choice here as well. Yeah. Once you have machines and algorithms that dictate what you're going to do, you've lost your freedom. You've lost your scope as an autonomous agent yourself. Yeah. And then on the other hand, what we don't have is machines that take initiative, that decide, come suddenly say, oh, I know what we need to do is bring together a whole load of people and talk about the future of work and have that idea. That's not a machine thing.
Or a machine deciding that it wants to learn to play Go, or wants to be good at Go, or that's like actually what it wants to spend its time doing the way, a Go champion does. So, in the spirit of what Patrick was saying about better understanding ourselves, I think this is something that we in our group and a lot of people in cognitive science and more sort of human-oriented AI are trying to understand is what does it really mean to have a goal on any scale, right? Because currently our machines don't really have goals. We give them we have a goal and we program them to help us achieve a goal. No?
No?
Yeah. You don't want that? Or I mean, I think we should ask ourselves how much we want machines to have goals, but in the spirit of understanding ourselves.
Friend Brad Templeton.
I mean, Josh, machines have had goals, in some sense of the word goal, since 1960, when Slagle's program solved integration problems. Goal. Whenever I use terms like goal, I always have to remind myself of Marvin Minsky's notion of suitcase word. He used that label for. He used that characterization for labels that can be applied to so many things that are like large suitcases you can stuff anything into. So so I would say in some respects, the kind of stuff I work on in story understanding, problem solving in stories, self-aware storytelling, self-aware robotics is the kind of stuff that Manuela was talking about. Sure, I think machines can have goals. I think they can have an aspect of self-awareness. All these things are suitcase terms, but I think we can flatter ourselves to say that we are beginning to understand how machines can have those kinds of things. And at the same time, just to address something you mentioned, I always come back to a long time ago when I had a pet raccoon. This raccoon had been, her mother had been shot, and somehow I found myself with a pet raccoon. This raccoon was incredibly smart, smarter than any dog I've ever had. It would, within a day or two, it learned how to open the refrigerator door, and she refused to eat anything but chicken wings until I hit on the idea of sticking a chicken bone through a hot dog, and then she'd eat that, especially if it was in a garbage can. But as smart as my pet raccoon was, I never thought that she would be able to build a machine that was as smart as she was. So it's a certain amount of human hubris that we have when we express confidence that we'll be able to build machines that are really smarter than we are in all aspects of what we mean when we say smart.
My friend Brad Templeton said that he didn't think there would be autonomous machines until his self-driving car decided to go to the beach for work. I think we're out of time, so thank you very much. Join the panel in thanking me.
Thank you.
That was great.